This question is asked in gate 23 of electronics. This is from signal system subjects and from classification of system topic. The question is, consider a system with input xt and output yt, where yt and xt are related by this equation. The system is, if you check the options, we are supposed to comment regarding its causal behavior and its time variance behavior. That is, whether the system is causal or non-causal, whether the system is time variant or time invariant. Okay. So the given equation is here yt is equals to x of e raised to power t. So how do you check the causality, whether the system is causal? How do you know this? So you have to check at different time instants. So at any time instant, if you observe that the present output depending on future value of inputs, we'll say it is a non-causal system. So for every time instant, if each and every time instant, if there is present and past dependency, then only it is causal. But at any time instant, if the present output depends on the future inputs, it is definitely a non-causal system. So how do you check it? By substituting different value of t. That's the usual methods. So here by substituting t equal to 0, let's say y of 0 is equals to x of e raised to power 0. So y of 0 is depending on x of 1. That means if this is a timeline, okay, so this is a time t equal to 0 and this is your time t equals to 1. So to produce the output at t equal to 0, you need the input at t equals to 1. To produce the output at t equal to 0, you need the input at t equals to 1, which is a future dependency. To produce the output at present instant, it needs inputs which is at future value with respect to the input time instant. So this is definitely a future time, dependency. So this is definitely a non-causal system. Now let us check regarding the time invariance and time variant property. So here the equation is yt is equals to x of e raised to power t. So first thing is, what is the delayed version of outputs? In other words, what is y of t minus t naught? What is the delayed version of output? So what is y of t minus t naught means wherever t is there, you have to replace it by t minus t naught. Okay. So the delayed version of output is, you have to replace t by t minus t naught. So if you replace the t by t minus t naught, you get this. Fine. So this is what the delayed output. Now, next thing is, what is the output with respect to delayed version of input? In other words, if x of t is the input, we are getting the output as x of e raised to power t. That means wherever t is there, this t is replaced by e raised to power t. But instead of xt, if I give the input as x of t minus t naught, then the output will be x of e raised to power t minus t naught. So this is what is the output because of the delayed inputs, right? Because the system is replacing t by e raised to power t. If the input is x of t minus t naught, so this t will be replaced by e raised to power t. You get this. So this is the response because of the delayed inputs, and this is the response which is a delayed output, right? So you have to check whether these two expressions are same or not. If they are same, it is time invariant system. If they are not same, it is time variant system. Now I can clearly see if I compare this and this, so they are not same. So because they are not same, I can say that this is a time variant system. So the answer is non-causal and time variant. So if you check this, non-causal and time varying, so this is given by only option B. So B is the right answer. Okay, very simple, straightforward PET model question of GATE exams. So because present output depending on future inputs, it is non-causal, and delayed output is not equals to output because of delayed inputs. So it is a time variant system. So the answer is non-causal and time varying option. This question is asked in gate 23 of electronics. This is from signal system subjects and related to the continuous time Fourier transform topic. The question is, let MT be a strictly band limited signal with bandwidth B, okay, and energy E. Assuming omega naught equals to 10B, the energy in the signal MT into cos omega naught T is. So these are the options they have given. So what is the data given, student, is, so you see here, MT be a strictly band limited signal with bandwidth B and energy E. So graphically, if I want to show it, okay, so how does it look like? So the time domain data is empty. So the frequency domain data, so if m of t having Fourier transform, let's say m of omega. So just for simplicity, I'm taking a rectangular pulse. There is no other reason behind this. So this is your m of omega. That means the Fourier transform of this signal is empty Fourier transform is m of omega. Let us assume m of omega like this. So bandwidth is b, means this point is b and this is your minus b. And what is the height? So you can take anything, let's say it is 1. So they're saying that energy is E. So this signal having energy E. So in the frequency domain, to calculate energy, we have the Parseval's theorems. Energy E is given by 1 by 2 pi integration of minus infinite to infinite. This will be magnitude of m omega whole square d omega. This is the formula to calculate energy. This is basically Parseval's relations, isn't it? So in this case, if you try to calculate the energy E, how much it will be E in this case? So in this case, I can say that it is 1 by 2 pi integration. There is no point to take minus infinite. I will be taking minus b to b, and in the minus b to b, magnitude of m omega is again 1. So it is your 1 square into d omega. So if you simplify this, this is 1 by 2 pi. This is d omega. If you substitute the limits, so this happens to be 2b. So 2 to cancel. So this happens to be b by pi. So that means this signal m of t, which is band limited to b, its energy is E, and the value of E, the example which I have taken for this case, is coming as b by pi. Now we have to calculate what is the energy of this signal, provided omega naught equals to 10b. Okay, so how do you find it? So let us say that this yt is m of t into cos of omega naught t. So what is your y omega? So this is nothing but the modulation property. This is given by half of m of omega minus omega naught plus m of omega plus omega naught. This is the standard modulation property. So if this is what is the time domain equation, this is what is corresponding frequency domain equation. So what is y of omega? So y of omega you can evaluate or you can draw using this relation. So m of omega is known to us. So m of omega is covering from minus b to b with height 1. So what is this m of omega minus omega naught? If you check it, omega minus omega naught. So let us directly substitute the omega naught value here. So they are saying that omega naught is 10b, right? So if I substitute 10b, so it is omega minus 10b. This is omega plus 10b. So if I ask you what is m of omega minus 10b, so this signal will be shifted towards right by 10b. So it will be covering the center frequency, which is 0 here. So this point will be 10b. This is your 9b. And this is your 11b. Similarly, this m of omega plus 10b, so its mirror image you will get in the negative frequency. So this will be from minus 11b. So this point will be your minus 10b, and this point will be your minus 9b. But the height, which was 1 earlier, because of this multiplying factor half, so this height is your half and this height is your half. So we are supposed to find what is the energy of this signal in terms of E, because E is b by pi. Then I have to calculate what is the energy of this, so that we can correlate. So how to calculate the energy of this? The energy of this is given by E of y. Okay, so this is again by Parseval's theorems, half of integration of minus infinite to plus infinite, this magnitude of y omega whole square d omega. So students, magnitude of y omega is, again it will be half only, because it's a positive real quantity. There is no effect of this mod function. So this happens to be half of integration of minus 11b to plus 11b. So we can divide into two parts. Otherwise it's an even function also. We can do some simplification of maths this way. Okay, so this is equivalent to 1 by 2, okay, 2 into 0 to infinite magnitude of y omega square d omega. I hope you agree, because it's a even function. If you square it, even into even function. So if it is even function, this integration is equivalent to 2 into integration of 0 to infinite y omega square d omega. That's what I'm writing here. So this is nothing but this 2 to cancel out. So this is 0 to infinite magnitude of y omega square d omega. So if you check 0 to infinite, so just you have to consider the positive frequency only. So here the frequency range is 9b to 11b and y omega square. So half square is 1 by 4 and this is d omega. If you simplify this, this is 1 by 4 and if you substitute the limit, it is 11b minus 9b. So that happens to be 2b by 4. 2b by 4. So one thing student I am missing is this is actually 1 by 2 pi, right? 1 by 2 pi. So here this 1 by pi will come. Here also this 1 by pi will come. Here it is this pi will come. And here also it is 2b by 4 pi. If you check this, this is coming as b by 2 pi, right? B by 2 pi. So Ey is coming as b by 2 pi. What was E? E was nothing but b by pi. So your Ey is nothing but E by 2. That is the energy of mt into cos omega naught t is equivalent to E by 2. So energy of mt into cos omega naught t is equivalent to E by 2 because E is b by pi. So the energy of this is coming as b by 2 pi. So I can tell that the energy of this signal is nothing but E by 2. If energy of this is your E, then energy of this is E by 2, which is given in option B. So this is also student because I am explaining, I have taken on 5 minutes of time, but if you solve in its own way in a proper flow, it will take hardly 3 to 4 minutes. So the answer is E by 2 for this, option B. This question is asked in gate 23 of electronics. This is from signal system subjects and from Fourier transform topic. The question is, the Fourier transform x omega of x of t equals to e raised to power minus t square is. So this is again a student very repetitive model questions in gate exam. I think 4 to 5 times this exact question has been asked. So this is in CTFT we study something regarding a Gaussian pulse which is in the form of e raised to power minus at square, right? So it's a Gaussian pulse and its Fourier transform is given by square root of pi by a into e raised to power minus of omega square by 4a. This is what the Fourier transform of a standard Gaussian pulse. The Fourier transform of Gaussian pulse is again a Gaussian pulse. The waveform of the time domain signal and the frequency domain signal, they look similar. So that's why Fourier transform of a Gaussian pulse is again a Gaussian pulse and it's a very standard relations. So now in this question, we are supposed to find e raised to power minus t square. If you check it, so I'll be substituting a equals to 1. So if I substitute a equals to 1, e raised to power minus t square, its Fourier transform will be square root of pi and this is e raised to power minus of omega square by 4. So this is what the answer will be. The Fourier transform this signal is this signal square root of pi into e raised to power minus omega square by 4, which is given in option C. So C is the right answer for this problem. This question is asked in gate 23 of electronics. This is from signal system subjects and related to the Fourier analysis topic. The question is, in the table shown below, match the signal type with its spectral characteristics. So this is what your time domain signals are and this is what your frequency domain signal are. What kind of time domain signal will be mapped to what kind of frequency domain signal? That is what the way the question is framed. So first one is continuous and aperiodic. Okay, so continuous and non-periodic signal. The classic example is CTFT. In CTFT, generally the time domain signals are of non-periodic and continuous time nature. So in this case, the frequency domain, if you check it out, so this is also continuous and non-periodic. So continuous and aperiodic, it will be transforming into again continuous and aperiodic. So one will be transferred to A. Okay, fine. Next, continuous and periodic. Continuous and periodic. What is that Fourier analysis where the time domain signal is continuous and periodic? So this is nothing but your CTFS, continuous time Fourier series. In CTFS, the spectrum is discrete in natures and it is of non-periodic in natures. The CTFS spectrum is discrete and non-periodic. So discrete and aperiodic. So 2 corresponds to C. So 1 corresponds to A, 2 corresponds to C. 3, discrete and non-periodic. So discrete and non-periodic. So what is that Fourier analysis where the signal is discrete and non-periodic? So that is nothing but your DTFT. So what is the DTFT spectrum nature? DTFT spectrum is continuous and periodic. So periodic of period 2 pi, it is continuous in nature. So continuous and periodic. So that happens to be B. So your third happens to be B. And discrete and periodic. The last one, discrete and periodic. Discrete and periodic. So this is nothing but your DFT or your DTFS. So in this case, what happens? The corresponding spectrum is again discrete and periodic. So discrete periodic corresponds to discrete periodic. So 4 corresponds to D. So ACBD. ACBD. I think it is satisfying by not ACBD, right? Yeah. ACBD, yeah. It is satisfying by option B. So B is the right answer. Okay, so this is basically, students, a standard observation model question, right? In every Fourier analysis topic, the first thing that the teacher teach to the student is what kind of signal are the time domain signal natures in this particular Fourier analysis technique, and if it is being if the Fourier analysis applied to this one, what is the nature of the corresponding transformed signal, right? So in CTFS, CTFT, DTFS, DTFT, DFT, that is what the first thing we discussed. What is the nature of time domain signal is applicable in this case, and if these signals are applied to this Fourier technique, what is the corresponding frequency domain signal? So we study those things, right? So this is basically a observation based questions. So the answer is option B for this. This question is asked in gate 23 of electronics. This is from signal system subjects and from DTFS topic. The question is, consider a discrete time periodic signal with period n equals to 5. Let the discrete time Fourier series DTFS representation of xn is given by this equation, where a0 is 1, a1 is 3j, a2 is 2j, a3 is minus 2j, a4 is minus 3j. The value of summation n equal to 0 to 4 xn into sine 4 pi n by 5 is what? So we are supposed to find what is the value. Let's say it is yn. So yn, if it is defined as n from 0 to 4 xn sine 4 pi by 5n, what is its value? So that's what we are supposed to find. So it's a good logical question, students. So if you go by without knowing property and all, it will be too lengthy, so much of calculation involved, but little bit brain if you use, it is hardly a 1 minute problem. Okay, first thing is, so in the DTFS, the coefficient is given by AK. So AK is defined as 1 by n, where n is the period, summation n from 0 to n minus 1, and this is xn into e raised to power minus j. This is 2 pi by n, 2 pi by capital N, and this is k, and this is n. Okay, so this is what is the standard DTFS coefficient formula. So what I can do is, so from this relation, I can see that summation n from 0 to n minus 1, okay, xn into e raised to power minus j 2 pi by n k into n is nothing but your n into ak. But in my case, in this problem, n is 5. So if I am using n is 5, so n minus 1, 5 minus 1, this is 4. Otherwise, let us write fresh. So this implies summation n from 0 to 4 xn into e raised to power minus j 2 pi by 5, and this is k into n is equivalent to 5 into ak. Okay, and one more thing, student, you should know that in the DTFS, the spectrum is also periodic. Signal xn time domain signal is periodic, and the spectrum is also periodic. In other words, what I want to say is ak will be same as ak plus or minus n. If the signal xn is periodic with n sample, then the spectrum is also periodic with the same n sample. So ak is equivalent to ak plus or minus n, because it is periodic. If you find the sample with plus n or minus n, it will be same. So we'll be using this as our base to solve this problem, and this property will be useful. Now let us come into this equation which is given. So this is what is the equation given. Okay, you see. So this I can write this as summation n from 0 to 4. So this sine 4 pi by n, so this can be splitted as, so this is n equal to 0 to 4, this is xn, this is e raised to power j 4 pi by 5n, okay, minus e raised to power minus j 4 pi by 5n divided by 2j, right? Because, so if I ask you what is sine omega naught n, it is e raised to power j omega naught minus e raised to power minus j omega naught divided by 2j. So now if I simplify this, so this will be equivalent to, so this multiplying factor 1 by 2j, let us keep it out, 1 by 2j, then it is xn into e raised to power j 4 pi by 5n plus summation again n from 0 to 4, again this 1 by 2j, but here it won't be plus, so because this is minus sign, so here I am putting minus sign, minus it is xn into e raised to power j, I mean minus j 4 pi by 5n. So now if I simplify this, it is 1 by 2j. Okay, now you see students. So this can be written as summation n from 0 to 4. This is x of n. See, the format is like this. So this is what the format is. You see this pattern, e raised to power. So I can, if I write in this way, it is e raised to power minus j 2 pi by 5. Now what is the value of k if I compare? So this is coming as minus 2 and this is n. Because if you see this one, so this is coming as plus j 4 pi by 5n, right? So this is same as this factor. And why I am writing this way? Because I have to make use of this standard relations. So here the pattern is minus j should be multiplied by 2 pi by 5 should be multiplied with k. So that's why I am writing this way. Okay, then minus this is 1 by 2j, again this is taken out, and this is n from 0 to 4. So this is x of n, and this is e raised to power minus j, and this is 2 pi by 5, 2 pi by 5, and then it is here 2, and this is n. So this is equivalent to 1 by 2j. So what is this? So this, if you see, this is a of minus 2, right? Because you see in this relation, if you substitute how much? If you substitute k equals to minus 2, so what do you get? You get this term, right? So this is, and again this 5 is also there. So it is 5 into a of minus 2, right? Because if you compare, okay, this relation, so what is the change? So in this relation, you simply make k equals to minus 2. If you make k equals to minus 2, don't you think this term is same as this term? Yes. If I am substituting k equals to minus 2 in this is same as this. So that's why you get 1 by 2j is anyway outside, and this is 5 into a of minus 2. And then it is minus, okay, this is again 5 into a of 2. But in the question, a of 2 is given to me. So what is a of 2 is given to me? So a of 2, if you see, this is given as 2j. So to simplify this, I need a2 and a minus 2. So a of 2 is j2. But I need a of minus 2. So a of minus 2 data is not given. A of minus 2 data is not given. You see, where a of minus 2 is there, a of minus 2 is not there. So that's why we have to make use of this property. So a of minus 2 is equivalent to a of minus 2 plus or minus n, which is 5 here. So a of minus 2 is equivalent to a of 3, or it is equivalent to a of minus 7. So a of minus 2 is equals to a of 3, and a of 3 is given in the question. So a of 3, if you see student, this is given as minus 2j. So this is your minus of 2j. So in this you need two data. You need a2 value is j2, and you need a of minus 2, which is equivalent to a3, which is minus j2. If you simplify this, it is 1 by 2j. So 5 into a of minus 2. So you get it is minus 10j. Because a of minus 2 is minus 2j. So 5 into minus 2 is minus 10j. Then minus 5a2. So minus 5a2. So 5 into j2 is minus j10. So if you check it out, so it is minus j20 divided by j2. So if you check it out, so j cancel out, we are getting this is minus 10. So this answer, if you check it out, so this is satisfied by option A. A is the right answer, which is minus 10. So it's a good standard logical problem. Okay. So from this relation, okay, you can easily figure it out. Okay, if you split it up, so this one, if you split it, so this is coming on this pattern. So just by observing, by finding the value of k, we got this relation, and by using the periodic property of spectrum, we obtained these two coefficients. I mean a of minus 2 we obtained, it was already given, and by substituting this, we are getting the answer as minus 10. So because again I'm explaining, I have taken around 5-6 minutes of time. If you solve in a proper flow, a intelligent student can directly reach into this equation. And then by further proceeding, you can get the answer in 2 minutes hardly. So the answer is option A for this, which is minus 10. This question is asked in gate 23 of electronics. This is from signal system subjects and from DTFT topic. The question is, let an input xn having discrete time Fourier transform x of e raised to power j omega is this equation be passed through an LTS system. The frequency response of LTS system is h of e raised to power j omega is given. The output yn of the system is okay. So this is a standard repetitive model question in the GATE exam. So sometime they are framing this model in Laplace domain, sometime using normal time domain convolution. This time it is in the discrete form, but in the DTFT concept they have used. So you know very well, if the input is x of n and the impulse response is h of n, then the output is y of n. And y of n is x of n convolution with h of n. But if I speak this in terms of DTFT, x of e raised to power j omega, and if I say the DTFT of h of n is h of e raised to power j omega, and the DTFT of y of n is y of e raised to power j omega, then y of e raised to power j omega is given by x of e raised to power j omega multiplied by h of e raised to power j omega. Okay, so if we get this y of e raised to power j omega, we can take its IDTFT to get y of n. So what we'll be doing is, so y of e raised to power j omega is equals to x of e raised to power j omega. So this equation, so which is 1 minus e raised to power minus j omega plus 2 into e raised to power minus j3 omega multiplied by 1 minus 1 by 2 into e raised to power minus j2 omega. So if we simplify this, so this will be how much? So okay, so it is 1 into this much, so 1 minus e raised to power minus j omega plus 2 into e raised to power minus j3 omega. So I have multiplied this 1 with this entire term, then I'll be multiplying this factor with this entire term. So if I do that, so you get minus half into e raised to power minus j2 omega, then minus into minus is plus half into e raised to power minus j2 omega, and this is e raised to power minus j omega. So it is e raised to power minus j3 omega. Again minus into plus is minus, 2 into half is 1 into e raised to power minus j5 omega, because if you multiply this term with the entire term, the first term is same as this one, so you get minus half into e raised to power minus j2 omega. Next is minus minus plus, then e raised to power minus j2, this is e raised to minus j3 omega. Then minus into plus is minus, then 2 into half is 1, so minus 1, and this into this is minus j5 omega. So if you simplify this further, so this is 1 minus e raised to power minus j omega. So I have considered this and this. Then this one, so it is minus half into e raised to power minus j2 omega. Then I can club this and this together. So 2 plus half is 5 by 2. 2.5 is 5 by 2 into e raised to power minus j3 omega. Then minus e raised to power minus j5 omega. So So this is what we are getting, and you know very well. So this is a standard relation, delta of n minus n naught, its corresponding DTFT is e raised to power minus j omega n naught. So this identity will be using, because everywhere you see it is in the format of e raised to power minus j omega n naught. So we can easily figure it out what is the time domain function using this delta of n minus n naught. So if I do that, so y of n is equals to 1 corresponds to delta n, then minus, so this corresponds to, if you compare with this, so your n naught value is 1. So you get, if you substitute n naught equals to 1 in this equation, it is delta of n minus 1. Then you have half of, this is minus, students, not plus. Then if you substitute n equals to 2 here, so you get this, so you get delta of n minus 2, then plus 5 by 2 of delta of n minus 3 minus delta of n minus 5. So this is what is you are getting. Okay. So if you check it, delta n minus delta n minus 1. So this is plus, this cannot be answered. Then delta n minus half. So this is fine, this is fine. Minus half del minus, this is fine. Plus 5 by 2 del n minus 3 minus this, yeah. So C is the right answer. Option B cannot be the answer, because so these signs are minus and plus. We expect plus and minus. So B is also not correct. And C, you are expecting plus delta n minus 1. We expect minus. This cannot be answered. So based on given data, so definitely answer is option C, which is this one. So you can solve this problem using jet transform also, or using time domain convolution also. But here this is very straightforward. Using this simple property, we can easily get the answer. So answer is option C for this. This question is asked in gate 23 of electronics. This is from signal system subjects, and this is based on the application of CTFT. The question is, let x of t equals to 10 cos 10.5 wt be passed through an LTI system having impulse response h of t. The output of the system is. So what data student given is, so we have the input x of t, which is 10 cos 10.5 wt. Okay, this is what is the inputs. This is being passed through a LTI system, and the impulse response of LTI system is pi sine wt divided by pi t, this whole square multiplied by cos 10 wt. So this is what is the impulse response of the system, and we are supposed to find what is the output yt. Okay, so one thing student you notice here, like this is a LTI system whose input is sinusoid and impulse response is given, and we are supposed to find the output. So this is again a regular model, but only one complicated thing they have introduced is the nature of this h of t. What is the regular model? The input is sinusoid, then the output of the LTI system is again sinusoid with the same frequency. So that's why if you see in all the option, because the input frequency is 10.5 omega, if you compare this with cos omega naught t, that omega naught is coming as 10.5 w. So you see in every option you have 10.5 w, because frequency of input and output, they never change with respect to LTI system if the input is sinusoid. So that's why frequency is same. The only thing, the deciding factor in the option is what about the amplitude. So amplitudes are only varying in all the options. So you have to be careful regarding the calculations. So what is the approach to solve this problem? We have to find the Fourier transform this h of t, that is we will get h of omega. We will evaluate what is that h of omega magnitudes at this input signal frequency 10.5 w. So that amplitude will be multiplied on the input signal. That will be my answer. And because it's a real and even function, its Fourier transform will be again real and even. It won't contribute anything on the phase. That's why you are not getting any phase term here. Phase is contributed by this one is basically 0. In other words, I mean to say that if x of t is given by a cos omega naught t plus phi 1, okay, if this is what the input is, then your output y of t is given by a into h of omega naught magnitudes cos of omega naught t plus phi 1 plus h of omega naught phase. This is what is the standard model, what I am saying. So here also you see here your omega naught in this case is 10.5 w, and phi 1 is basically 0 in this case, right? So just we have to find this h of omega, and here because this h of t is real and even, so we expect that h of omega is also real and even. In this case, what happens? If you find the phase of this h of omega, you get it is 0. So in other words, we will be finding what is a of omega naught value in this case is 10.5 W. What is h of 10.5 W? This is cos of 10.5 W t. The phi 1 value is 0 here. I mean, you see there is no phase here. So phi 1 is 0 and this will also be 0. So it is simply only this much you will get. So just this is what your answer is. So if you see this, so what is A by the way? So A, student, also if you compare here, A is the input signal amplitude, so it is 10. So it is here also it is 10. So this is what my yt would be. So the only thing that you are supposed to find in this case is only this factor. What is h of 10.5 W magnitude? So that if you find, if you simply multiply with 10, so that will give you the answer. So my target is to get this. So here the notation omega and W, they are quite similar. We have to be a bit careful while writing it. So let us first find what is h of omega, that is the Fourier transform this h of t, and in that we will be substituting this 10.5 W, that will give my answer. So to start with, h of t is given as, okay, which is pi sine Wt divided by pi t, this whole square into cos of 10 Wt, cos of 10 Wt. So let us say that h of t is equals to gt into cos of 10 Wt. Okay, gt into cos of 10 Wt. What is gt? So here I mean that gt is equals to pi sine Wt divided by pi t whole square. This is what your gt is. If it happens, then h of omega is equals to half of, this is g of omega minus 10 W, okay, plus g of omega plus 10 W. This is by modulation property, right? So gt into cos omega naught t having Fourier transform, half of g of omega minus omega naught, half of g of omega minus 10 omega plus g of omega plus 10 omega. So, so in this we have to substitute this h of what? H of 10.5 W. That is, if you substitute omega equals to 10.5 W, this become half of g of 10.5 W minus 10 W. So when I'm saying pronouncing W and omega, you please distinguish. I don't know omega and W, they are looking similar. So in place of omega here, okay, in place of omega here, this omega, I'm substituting here 10.5 W. So this is g of 10.5 W minus 10 W plus g of 10.5 W plus 10 W. So this is equals to half of g of 10.5 W minus 10 W is 0.5 W plus g of, this is 10 plus 10.5, this is 20.5 W. This is what? This is nothing but your h of 10.5 W. Okay, so we'll be having this. So the ultimate thing now left for us is to get this Fourier transform g to g omega, and that g omega will be substituting this 0.5 W and 20.5 W. That will give my answer. So to start with now, my gt is given as how much? Pi into sine Wt divided by pi t whole square, isn't it? Yeah. So student, so if I ask you what is the Fourier transform of sine Wt divided by pi t, so this is the impulse response of standard ideal low pass filter. It is given by a rectangular pulse having height 1, and this covers from, this is sine at by pi t, it covers minus a to a. So here a is W, so this covers from minus W to plus W. Note that this is omega and these are some specific value of omega which are W and minus W. So this is sine omega t by pi t. Now if I say sine Wt by pi t, multiplied by sine wt by pi t. So what is the Fourier transform of this? So you know very well, we have the multiplication property, that is x1t multiplied by x2t. Its Fourier transform is 1 by 2 pi. Then it is x1 omega convolve with x2 omega. Right? So similarly, if I am multiplying two signals, so I have one additional multiplying factor 1 by 2 pi, I mean this one, and then convolution of this pulse with this itself, because in this case both of the signals are same, so you have to convolve this pulse with itself. And you know very well, whenever you convolve two rectangular pulses of equal width, the answer happens to be a triangle. If unequal width, then it is a trapezium. If equal width, it is definitely a triangle. Right? So how do you draw the triangle then? So first thing is you have to decide the limits. So here it is minus w plus minus w, it is minus 2w. Similarly, w plus w, it is 2w. This is the omega axis. So this is how the Fourier transform will look like. But what about the amplitudes? So to find the amplitude, you know the slope. So slope is basically product of this height and its other height. I mean 1 into 1 is 1. So this slope is 1. So if this slope is 1, then this should be 2w. Because if this is 2w, then height by width, 3w by 2w, this is becoming 1. So you are getting this. Okay. So if I am multiplying sine omega t, sine wt by pi t, sine w by pi t, so this is what is corresponding Fourier transform is. But now my task is there is one additional factor of pi. So if this is pi and this is sine wt divided by pi t, this whole square, its Fourier transform will be how much? This is the same rectangle, but the amplitude will be scaled now. So this is from minus 2w to plus 2w, and this amplitude would be, okay, this pi is multiplied, so you get pi into, this was 1 by 2 pi, you get 1 by 2 pi, and then this is 2w. So this is your 2w. You have to multiply this. So now if you check it out, so this pi and this pi cancel out, these two and these two cancel out, so it is simply, it is w. Yes or no? So this is coming as simply w. So I can tell, so this is your what? GT, right? So this is your GT. So GT having Fourier transform g omega, which is this triangle. So this is minus 2w to plus 2w, and this is your w, this is your omega axis. So this is your g omega. Okay, so you got g omega. So now you have to find these things. G of 20.5w and g of 0.5w. Okay. So this is half is whole multiplied friends. Okay, this is whole multiplied. So g of 20.5w. So this is your 2w. So 20.5w is somewhere here. So I can see here g of 20.5w. So this is definitely 0 because this is existing between minus 2w to 2w. So beyond this it is 0, right? 20.5w is way beyond this. So this is definitely 0. And what is the other thing you need? You need g of 0.5w. So g of 0.5w. So g of 0.5w, you have to find it out. So where is this g of 0.5w? 0.5w, this is your 1w. So this will be your 0.5w. So this is the point, it is 0.5w. So this amplitude. So this amplitude you have to find it out. Okay. So how do you find it out? So first thing is, what is the slope of this line? So slope of this line is height by width. Height is w, width is 2w. W by 2w is basically half, and because it is falling, it is minus half. So slope is minus half. If slope is minus half, so the starting amplitude is w. So if I ask you what is the amplitude at 0.5w, it is starting amplitude is w minus, okay, the slope. Slope is, this is how much? Half. So half, and this is how much? 0.5w. Otherwise you can do your own maths, no issues. So if you calculate it, So this is coming as W minus 1 by 4W. So this is 1 by 4W, right? Yeah, 1 by 4W. So if it is 1 by 4W, so this is 4W minus W divided by 4. So this is coming as 3W by 4. Right? 0.75, yeah, 3W by 4. So you got this is 3W by 4. I think this calculation is okay. You understood this. Initial amplitude and then it is falling at the rate of minus half. So initial amplitude minus half is the amplitude and you need at this value 0.5 W. So W divided by W by 4, that happens to be 3W by 4. So these two data we can substitute in this equation. Which equation? This equation. So it's a bit lengthy question. You have to have patience. Then your H of 10.5 W happens to be half of this is 3W by 4 and this is 0. So this is 3W by 8. You got this. And if I ask you to take the magnitude of this, so it's a real and positive quantity. So this is also your 3W by 8. You got this. This is 3W by 8. So now you got this and you need this one, right? Your final answer is this one. So now you can simply substitute this quantity here. If you substitute it here, so your Yt is equals to 10 into this is 3W by 8. This is cos of 10.5 Wt. So 30 by 8. So 30 by 8 is 15 by 4. You get this is 15 by 4 W and this is cos of 10.5 Wt. This is your Yt. So Yt is 15 by 4 W into cos 10 pi t. 15 by 4 W cos 10.5 omega t, which is given in option A. 15 by 4 W is the amplitude you are getting of the final output. So this is the answer. So I know, student, this is a bit lengthy. You need to have patience while doing the calculation. It will take at least 7-8 minutes. It's a lengthy question. And because amplitude is what is asked, you have to be very careful regarding the calculation. If at any point if you are missing to calculate the slope and other things, so you may lose somewhere in between, right? So this is what is the answer, which is option A, 15 by 4 W cos 10.5 Wt. So to summarize, what I did in this question is, so we know that if the input is sinusoid, output is sinusoid. So this is what is the format of the output. Then I came to know like I need this quantity. So that means I have to find the Fourier transform of this. Because this is looking a bit complicated, so I have taken this on a GT. So I have assumed this is GT. Then H of t I can express it this way. So if I find this Fourier transform, I am getting this. And because my requirement is this one only, so I am substituting it here, so I am getting this. So now the problem is to get the value of g omega. So GT is defined like this. So its Fourier transform is this one. Then if you multiply this with this, you are getting a triangle like this. And again, if there is additional factor, you are getting this. So this is your g omega you are getting. So you got g omega. And as per this equation, you need g omega at 0.5 W and 25 W. So by observing the waveform, then 20.5 W it is 0. And then at 0.5 W it is coming as 3 W by 4. Then by substituting this thing, so in this equation, we are getting it is 3W by 8. And then if we, multiply this with this equation here, so you are getting it is 15W by 4 cos 10.5 Wt. So the answer is option A for this. This question is asked in gate 23 of electronics. This is from signal system subjects and from the sampling concept. The question is, let x1t and x2t be two band limited signal having bandwidth b equals to 4 pi into 10 raised to power 3 radian per second each. In the figure below, the Nyquist sampling frequency in radian per second required to sample Yt is. So you are supposed to find the sampling frequency of Yt. So let us assume that this is your y1t and this is your y2t. So Yt is equals to your y1t plus y2t. Okay, so suppose y1t, its maximum frequency is omega m1 and its maximum frequency is omega m2. Okay, I mean the maximum frequency of y1t is omega m1 and this is omega m2. And when adding two signals, okay, when you are adding two signal omega m1 and omega m2, what is the maximum frequency of yt? So I can tell that yt having maximum frequency is equals to, if you add two signal, so it will be basically what? Maximum of omega m1 comma omega m2. So if you are adding two signals, so it is basically union of this thing, right? So you get the maximum frequency is nothing but equals to the maximum frequency of those two signals which you are adding. So this is what you get yt, the maximum frequency, this much. So what is the sampling frequency they are asking? So the sampling frequency omega s, it will be equals to 2 into maximum frequency of omega m1 comma omega m2. So just we have to find omega m1 and omega m2 and we have to substitute here. That will give us the answer. So x1t, okay, x1 omega, if I ask you, so x1 omega, this is your x1 omega. So this point, this bandwidth is given 4 pi into 10 raised to power 3 radian per second. This is your omega axis. So this is how much? 4 pi into 10 raised to power 3 radian per second. This is x1 omega. Okay, and okay, x2. Okay, x2 is also having having bandwidth. Okay, so this is x1 omega, and let's say x2 omega. Let's say this is of this shape. This is again, this is your x2 omega, and this is your omega, and this point is again 4 pi into 10 raised to power 3. So now the thing is, when this, if I speak regarding y1t, what is your y1t? Y1t is equals to x1t into cos of 4 pi into 10 raised to power 3t. So what is your y1 of omega? Y1 of omega is basically half of x1 of omega minus this quantity, if I say omega x plus x1 of omega plus omega x. So naturally, if I ask you what is the maximum frequency of y1 omega, so in this you will be adding this omega x. So omega m1 happens to be 4 pi into 10 raised to power 3 plus this, this is the same 4 pi into omega x is basically 4 pi into 10 raised to power 3, right? So this is 8 pi into 10 raised to power 3. This is omega m1. In the same logic, omega m2, if you find it out, so it is 4 pi into 10 raised to power 3. And here you see, this is what this thing is. So if you see, in this case, this 4 pi, it will be 12 pi in this case. So 4 pi into 10 raised to power 3 plus 12 pi into 10 raised to power 3. So this is basically 16 pi into 10 raised to power 3. This is your omega m2. So this is then omega s is twice of maximum of 8 pi into 10 raised to power 3 comma 16 pi into 10 raised to power 3. So this is 2 into, so maximum of this thing is this one, 16 pi into 10 raised to power 3, which is 32 pi into 10 raised to power 3 radian per second. So this is what is the sampling frequency of yt. So 32 pi into 10 raised to power 3, if you see, this is given option D. So D is the right answer for this problem. So which is 32 pi into 10 raised to 3 radian per second. So this is very simple problem again, the regular model questions. So by observing the block diagram, we obtain the signal yt is y1t plus y2t. And in the addition format, the maximum frequency happens to be maximum of the individual frequency. So then the sampling frequency is twice of this maximum frequency. So then by using modulation property, you can get the maximum frequency of y1t and y2t. So which is the 4 pi into 10 raised to power 3 plus this 4 pi into 10 raised to power 3. This is for omega m1. And for omega m2, it is this 4 pi 10 power 3 plus this 12 pi 10 power 3t. So omega m1 is coming 8 pi and 10 power 3. Omega m2 is coming 16 pi 10 power 3. So if you take maximum of this, you get 16 pi 10 power 3. So 2 into this thing is 32 pi 10 power 3 10 per second. So answer is option D for this. This question is asked in gate 23 of electronics. This is from signal system subjects and from convolution topic. The question is, let x1t is given this expression and x2t is shown in the figure below. If yt equals to x1t convolve with x2t, what is the value of integration minus infinite to infinite yt dt? So students, this is a common sense, like asking what is the answer of this integration is equivalent to nothing but area of yt, because integration always gives area under the curve. So asking this answer is equivalent to area of yt. So what is this yt? So yt is given as x1t convolve with x2t. So area of x1t convolve with x2t. So we have a property in convolution, like if two signals are convolved, the area of the convolved signal is multiplication of the individual area. In other words, area of x1t convolve with x2t is equivalent to area of x1t multiplied by area of x2t. Area of x2t. So x2t area, what is the area of x2t? So it is the impulse, its area is 1, its area is 2, 3, and about this rectangular pulse, the width is 2 and height is 1. So 2 into 1 is 2. So area of this function is 1 plus 2 plus 2. So this is 5. Area of x2t is 5. And what is the area of x1t? x1t is this function. If you plot it, so it's a rectangular pulse. It will cover from minus 1.5 to 1.5 with height 1. So what is the area of this? Area of this is width is 3 and height is 1. This is 3. So area of x1t is 3. Area of x2t is 5. So 3 into 5, 15 is the right answer. Okay. So answer of this problem is 15. It can be solved in any other complicated way by using Fourier transform, using Laplace and all, but those are all baseless. This is one of the most simplest approach. You should know the property. Area of convolved signal is multiplication of individual area, and the function which are given are very much straightforward to evaluate their area. So by evaluating their area, this area is coming 5, this area is coming 3, 5 into 3 is 15 is the answer. Very simple straightforward question. Answer is 15.